Hello, welcome to Amekadam's channel. In this lecture, we will see designing of low pass filter. The specifications are as follows. We have to design the maximally flat filter. So it is also known as Butterworth filter using lumped element which has a passband from 0 to 3 GHz and attenuation of at least 20 decibel at 5 GHz. And they have mentioned the characteristic impedance as 75 ohm. So we'll note this data over here. So I will write maximally flat. It is also known as Butterworth filter. The cutoff frequency they have mentioned as 3 GHz. The attenuation A is equal to 20 dB and the corresponding frequency we denote it as F1 as 5 GHz and R0 is mentioned as 75 ohm. So first aim is to calculate the order of the filter, and the order of the filter is calculated as, for the Butterworth, the formula is given as order of the filter n which is equal to log to the base 10 to the power a by 10 minus 1 divided by 2 log to the base 10 f1 by fc. Here in the denominator we will have f1 by fc if the filter is low pass filter, otherwise it will be fc by f1 for high pass filter. So let us substitute all these values and calculate n. So here it will be 10 to the power, it will be 20 by 10, so it will be 2 and here it will be 5 by 3. So it is given as logarithm, this will be 99, 100 minus 1, otherwise you can enter the actual values, divided by 2 divided by logarithm of 5 by 3. So it turns out to be, n turns out to be 4.49. But we want more than 20 dB attenuation, so we'll make n is equal to 5. So we have determined the order of the filter and it is n is equal to 5. Now we have to obtain the coefficients for the low pass filter. These coefficients are given for G0 is equal to 1, that is the normalized conductance is equal to 1, and omega c is equal to 1 Hz. FC cutoff frequency FC is equal to 1 Hz. After which we will go for the impedance and frequency scaling to obtain the corresponding values. So the coefficients are given as GK, which is equal to twice sine 2k minus 1 pi by 2n, where k is running from 1 to up to order n. So we will have G1, we will have G2, G3, G4 and G5. So let us calculate this thing. So I will enter this thing as a formula over here. So it will be 2 into sine 2 into alpha a. So I can change the value of alpha subsequently, minus 1. Since your calculator is in degree mode, we have to substitute pi as 180 into 180, and here it is 2 into n, and n we have calculated, n is equal to 5. So we'll go on calculating the values of these corresponding G's. So calculate for 1. So it turns out to be 0.618. Calculate for 2. 1.618. Calculate for 3. It is coming around to be 2. Now as we know that the order is odd number, the G1 will be equal to G5, G2 will be equal to G4. Otherwise we can also substitute the values of K as 4 and 5, and later on we can check. But if the order is too high and it is an odd number, then we can use this simple method where G1 will be equal to the last one G5 and so on. So G4 will be again 1.618 and G5 will be 0.618. So these two values are equal, then these two values are equal, and this is the central value. So we have determined the coefficients. Now we have to design the draw the low pass filter prototype for this one. So your low pass filter, you are designing low pass filter. So the first element, that this is of course the solution 1. We have two types of solution over here. We'll see both the solutions one by one. So in solution 1 you have inductor as the first element, then capacitor in the shunt element, inductor, capacitor and inductor. So since the order is 5, I have selected these 5 elements. So I have L1, C2, L3, C4 and L5. Now we have to calculate the values of these components. So L1, C2, L3, C4 and L5. These values are directly related with corresponding G. So L1 will be related with the G1, C2 will be related with G2, L3 with G3, C4, G4, L5 with G5, being a low pass filter. Now we have to apply the impedance scaling over here. So impedance scaling is applied like this. For inductor it will be multiplication by R0, and for the capacitor it will be division by R0. Now we'll apply the frequency scaling over here. So in frequency scaling we divide by the cutoff frequency for all the elements. So no need to memorize the formula, just remember this thing. For designing of the low pass filter, if one has to calculate the value of inductor, we have to multiply by R0. For the capacitor it will be division by R0, that is characteristic impedance. And frequency scaling, it is always division by omega c. So we'll substitute the values of G1, G2, G3, G4, G5 that were calculated. So we'll substitute these values over there. R0 they have mentioned as 75 ohm. So just I will show the calculation of one of the element. So it will be 0.618 into 75. Now be careful, here they are writing omega c. So it is 2 into pi into fc, and fc is 3 into 10 to the power 9 gigahertz. Students always, most of the times, do mistake over here. They substitute fc over here, but this is omega c. So it has to be converted into in terms of fc it will be 2 pi, omega c will be 2 pi fc. So we'll calculate this thing. So 0.618 into 75 divided by 2 into pi into 3 into 10 to the power 9. So it turns around to be 2.459 nanohenry. So this value will be again same. C2 and C4 will calculate. So C2 will be G2, that is 1.618 divided by 75 into omega c, that is 2 into pi into fc. So it is 3 into 10 to the power 9. So it turns out to be 1.145 picofarad. and L3 value turns out to be 7.957 nanohenry. So we have calculated the values, and now we'll complete the circuit diagram. Here you will have R0 at 75 ohm. You will have the source over here, and here you will have the load resistance 75 ohm. So this is my port 1 and this is my port 2, and the elements are connected in this manner in solution 1. Now we'll proceed for another solution, that is solution 2, for the same specification, but here I will select the first element as capacitor, and being a low pass filter, the capacitor has to be connected in the shunt arm, that is parallel arm. And now you will have inductor, capacitor, inductor and capacitor. So I will have C1, L2, C3, L4 and C5. Okay, so we'll calculate these values. So C1, L2, C3, L4 and C5. These values are directly proportional in terms of to their corresponding values of G, being a low pass filter. Now we have to apply the impedance scaling. So for capacitor it will be division by R0. For inductor it will be multiplication by R0. And for frequency scaling it is always division by omega C. So we'll substitute the values of corresponding G. So I will just show the one calculation. So 0.618 divided by 75 into 2 pi into 3 into 10 to the power 9. So it turns out to be 0.437 picofarad. So C1 will be equal to C5. L2 turns out to be 6.44 nanohenry. And C3 turns out to be 1.41 picofarad. So these are the component values. Just I will complete this circuit diagram. So I will have characteristic impedance 75 ohm as RS and RL, and I will have source over here. So for every problem, two solutions are possible in filter design. One considering the inductor as the first element in the series arm for a low pass filter, and another solution is possible where capacitor is considered in the vertical arm as the first element for a low pass filter. So in the next lecture we will see one more numerical where the order of the filter, even the Butterworth filter, turns out to be an even number. Thank you.